Okay, compound inequalities part 2. Word problems, your favorite, and interval notation. The acidity of the water in a swimming pool is considered normal if the average of the 3 pH readings is between 7.2 and 7.8 inclusive. Now there's some key words that you've already heard here that you need to make sure you take note of. The first one is between. That indicates that the value that you're going to be looking for is between 7.2 and 7.8. So we know that 7.2 and 7.8 are going to be on the two sides. And what you're looking for is going to be here in between. Inclusive means that the 7.8 and the 7.2 are included in that. So we can put a bar here, or equals to bar. Since it has to be between 7.8 and 7.2, that means it cannot be more than 7.8. So it has to be less than. Since it has to be between 7.2 and 7.8, it can't be less than 7.2. It has to be more than 7.2. So whatever goes here has to be more than 7.2. The thing we've now got to figure out is what goes here in the middle. Okay, it says the first two readings for a swimming pool are 7.4 and 7.9. What possible values for the third reading, P, will make the average pH normal? So we're looking for an average. Now how do you find an average? Typically you add things up and then divide by the number of items that were in what you added up. Well, here we've got a 7.4 and a 7.9, and our third reading is P. So we're going to add up 7.4 plus 7.9 plus P. And we're going to divide by 3 because there are 3 items. And so now we've written our inequality just by reading what we've had up here. So we go 7.2 is less than or equal to 15.3 plus P over 3 is less than or equal to 7.8. Now we've got to get rid of that 3 that's on the bottom here, so we multiply all sides by 3. Three times 7.2 is 21.6. It's less than or equal to. These cancel each other out, and we're left with 15.3 plus P is less than or equal to 23.4. Now we need to get rid of the 15.3 so that P will be by itself. So we go minus 15.3 on all sides. That cancels out. We're left with P. Put the signs. 23.4 minus 15.3 gives us 8.1. And 21.6 minus 15.3 gives us 6.3. So our answer is between 6.3 and 8.1. To earn a B in your algebra course, you must achieve an unrounded test average between 84 and 86 inclusive. Key words here, between and inclusive. So we know it's going to be between 84 and 86. It's going to be inclusive. That means it's going to be equal to 86 or 84. It's got to be between 84 and 86. So that means it cannot be greater than, it's got to be less than 86, and it's got to be more than 84. But what has to be more than that? Your average has to be more than that. And how do you find an average? You add up all the items in the sample space, then you divide by the number of items. Well, it says you scored an 86, an 85, and an 80 on the first 3 tests. So that's an 86, an 85, and an 80 on the first 3 tests. And it says, what possible scores can you get on the 4th one? Well, you don't know the 4th one. So when in algebra, when you don't know something, that means it's x. So we put our x up here. What are we going to divide by? Well, we have 1, 2, 3, 4 items in our sample space here. So we'll divide by 4. And now it's just a matter of solving to figure out what our score needs to be. So we've got 84 is less than or equal to 86 and 85 and 80 make 251 plus x over 4 is less than or equal to 86. To get rid of the 4 that's on bottom, we multiply all sides by 4. 4 times 84 is 336, is less than or equal to 251 plus x, which is less than or equal to 344. We need to get rid of the 251, so we go minus 251, minus 251, and minus 251. And that leaves us 336 minus 251 is 85. It's less than or equal to, that cancels out, you're left with x. And 344 minus 251 is 93. So as long as you make between an 85 and a 93, you'll have a B in your algebra course. Okay, now interval notation. Write this in interval notation. This is -3 and 6, and everything has to be in between there. So we write our -3 and our 6. That indicates that everything is between -3 and 6. The question is does it include the -3? Well, you can see here it's got an open dot. That means it does not include -3. When it does not include, you put a parentheses. When it does include, like it does here with the 6 with the closed-in dot, you put a bracket. Okay? So this means from -3 to 6, but not including the -3 and including the 6. Okay, write this one in interval notation. This time it is, well, let's go back to the previous one. This is a combination, an overlap of two graphs. The graph of less than or equal to 6 and the graph of -3, x is greater than -3. This is an overlap. So that meant that we're going to have one interval notation here. On this one, we've got two graphs going in opposite directions. So this is a combination. That means that this is going to be an OR statement. So this is going to be an OR. This is less than -3. So that means we're going to put our -3 over here with a parentheses because it does not include the -3. Where does it go to? Well, it goes to -infinity. And we can never get to infinity, so we put a parenthesis there to indicate that you can't reach infinity. Over here on this side, we're going to have 6 to infinity. Does it include the 6? Yes, it does, so we put a bracket. And once again, you can't get to infinity, so we put a parentheses over there. Write in interval notation all real numbers that are less than or equal to 4. So if it's going to be less than or equal to 4, we're going to start with the 4 over here. And we're going forever to the left because it's less than. So it goes to -infinity. Now, does it include the 4? Yes, it does. So that means we put a bracket. And once again, we put a parentheses anytime we have infinity there.